Hello, Sir Inc. students. Welcome to the test correction for Chapter 4B Test 4.4, 4.5, and 4.7, Version A. And today, we'll be discussing the first question. Find the horizontal phase shift for y equals cos 1/4 x plus pi over 2. Now, the first thing we're going to do is to find the horizontal phase shift, we have to find C. So first, we're going to write down the equation. Cos 1/4 x plus pi 2. Now what we're going to do here is we're going to factor out the 1/4 because x has to be by itself. So that's going to be cos 1/4 x plus. Now since the 1/4 was factored out, so we have to find the reciprocal for pi over 2. So that'll be pi over 2 divided by 1/4. Extend that. Now if we do the equation pi over 2 divided by 1/4, that will become cos 1/4 x plus pi squared. So now that we factor out the 1/4, we have to find C. Now C is x minus C. Since we have a positive here, we're going to turn this to, so that's going to become x minus pi squared. So now that we have that, we'll take this out since x minus C. We'll take this. And then it's going to become pi squared. And since it's negative, it's going to go to the left. So it's going to go to the left. And that's going to be your answer for C. So there you have it. The answer is C. So have a fun, safe leave weekend, everyone. And I love math.
The problem number 2 asks you to find the value of inverse tangent radical 3. The first step is to set it to an equation which you already have. You can set it to any variable. The next step is to find the inverse of the problem. So what you're going to do is you're going to switch radical 3 and y. So the new problem is going to be tangent, and then the negative 1 from the tangent also goes away.
For step 3, you're going to find the restricted domain, and for tangent, that's negative pi over 2 to pi over 2. Now, since tangent is y over x, we have to use a unit circle. And we know for tangent of radical 3 is pi over 3 and 4 pi over 3.
Alright, so for this problem, since we want to make the denominators the same, so for restricting the domain, we're going to want to times it by 3. So then it'll become out, if you go over here, it'll be negative 3 pi over 6 and then 3 pi over 6. And then we're going to want to times this by 2. So then it'll be 2 pi over 6 and then 8 pi over 6.
So with our new restricted domain, which is negative 3 pi over 6 and 3 pi over 6, the only number that can fit is 2 pi over 6. 8 pi over 6 would not fit even if you did use coterminal angles. So our new answer is tangent of y equals pi over 3.
So our question is, given the function y equals 3 minus 2 cosine parentheses 4x minus 5 parentheses, determine the period and phase shift. So first we have to rewrite the question, but first before we find a, b, c, and d, we have to factor out 4. So the 4 goes outside the parentheses, and then that's how it's gonna look like factored out. Then now we have to find the a, b, c, d. So for a, it's gonna be negative 2, but we have to that turns into a positive. And that's the amp. Then next, to look for b, it would be 4. But for b, that we're not done yet. We have to look for the period, which is 2 pi over b, and we just insert 4 into b. And that's gonna simplify into pi over 2. And for c, that would be 5 over 4. And d is 3. So for the question, we're supposed to determine the period and the phase shift. And the period would be pi over 2. And out of these two questions, these two cancel out. And for the phase shift, c is the phase shift. And since it's positive, we move to the right, and that would be b.
First, you take arc of cosine radical 2 over 2, you set it into an equation, and then you take the inverse of it, making it so that it's in the first quadrant of the unit circle.
Okay, so then you do the Pythagorean Theorem, which is y squared plus x squared equals r squared. And so you plug in the numbers from the triangle and then you solve it. And then once you solve it, you get radical y squared equals radical 2. And then what you would get is y equals radical 2.
Since you're looking for the tangent, which is y over x, you take radical 2 over radical 2, which equals 1.
I love math. You don't love math? What's wrong with you?
Alright guys, so today we're going to be solving the problem cosecant of the inverse of tan x over radical 3. Now, this parenthesis here is not part of cosecant, it is part of another problem, so for that we will substitute with beta. And beta is equal to the parenthesis, so then beta is equal to the inverse of tan x over radical 3. And what you do is you switch x over radical 3 with tan beta so that it could be with tangent. So then you get rid of the inverse, so then the tangent of beta is x over radical 3. Now this isn't on the unit circle, so then we have to figure out how to put it on an actual triangle. So then we use tangent, which is y over x. Y would be x, and then x would be radical 3, which is shown here. And so to find r, we need to use the Pythagorean Theorem, which is r squared is equal to x squared plus y squared. So then that would equal to radical 3 squared plus x squared. Radical 3 squared is 3, because if you use the radical, it would be radical 3 or whatever. And then x squared is just x squared, because x squared did not have any numbers with it, so it just is x squared. So then we have r squared is equal to plus 3 plus x squared. And so we have to take the square root, and then that would be r is equal to the radical of x squared plus 3. And then the problem asks us to find the cosecant of this problem. So then therefore, cosecant, which is equal to r over y, so we have all of those variables, so then it would equal to radical of x squared plus 3 over x.
Yay!
Yay!
Alright, so we're doing problem 9, and we have to graph it over one period, and the table of values, do a table of values and label the axes. First we're going to take this and we're going to turn it into cosine, which will be y equals negative 2 minus cosine 3x plus pi over 4. And then we will do and then what?
It's like really loud.
Problem 9. First, we're going to make sure to graph over one period. We're going to do a table of values and label the axes. So what we're going to do first is we're going to turn this equation into cosine, which will be y equals -2 minus cosine, and then 3x plus pi over 4. And then because it's pi over 4, we're going to take, we're going to turn this first. So once again, minus 2 times cosine, and then we're going to do 3 times x plus pi over 12. And then what we're going to do to make this is we're going to identify, so A, B, C, and D. The B value is, oh, where'd it go? 3. So the B value is 3, but the period, it will be, I think it's 2 pi over 3, and then amplitude is 1. -1, I mean. -1. And then C, which is the, what's it called? Phase shift? Okay, so it'll be pi over 12. And it'll be left. And then we take D, which is over here, and it will be -2, meaning we go down. So now we set up the equation. Let me erase this real quick. The equation. Okay. The equation. We put 0 less than or equal to, and then we put this in, which is 3x plus pi over 12, and then once again, and we put period, which was 2 pi over 3, right? Let's see. Yeah, 2 pi over 3. That's good. Okay, and then we're gonna divide by 3 on each side. That's what goes out. And we get 0 again, and then x plus pi over 12, and then 2 pi over 3. And then we're gonna do 4 over 4. Multiply by 4 over 4. So we can make common denominator. And then it turns into 8 pi over 12. And then we're going to subtract pi over 12 on all these sides. And then so pi over 12 again. So we get, I'm gonna erase this part because I'm running out of room. Okay, so we get pi over 12, negative pi over 12, right? And then right here we get x, and then we get, so we have 8 pi over 12, right? And we subtracted pi over 12, which we get 7 pi over 12 to get this. And then we will do our table. So our table, first we need to put our 5 points. So we have 1, I did not leave enough room. 2, wait, no, this is not going on. Okay, so here is 0, and we will have another one right here, 2, 3, 4, and 5. Yeah, 1, 2, 3. Wait, did I do this right? 1, 2, 3, 4. Yeah. So it's okay. And this will be our points right here, and we're gonna put them as negative pi over 12. And this will be positive pi over 12. This will be pi over 4. 5 pi over 12. And 7 pi over 12. Plug ourselves on the graph. And then we're gonna put in right here, right? I think so. I really should have made these tinier. Okay, and then we're going to take our table. So we're going to put x equals. And then we're going to put in these. So we're going to put negative pi over 12, which we, and then x plus pi over 12 will be over here. So we put negative pi over 12, and then we get pi over 12, pi over 4, 5 pi over 12. I need more room. And then we'll put some pi, or we'll move this over. 7 pi over 12 will be over there. Okay, and then, so we take that and we get 0 for over here. And then pi over 12 plus pi over 12 is pi over 6. Then we get pi over 3, pi over 2, and 2 pi over 3. And then we take, multiply by 3. Yeah, we multiply by 3, right? And then you get 0. Pi over 2, pi, 3 pi over 2, and then 2 pi. And then cosine, which is 1, 0, negative 1, 0, 1. And then we get, you multiply by negative 1, right? So you get negative 1, 0, 1, 0, negative 1. And then we take the, we add negative 2. So then we get negative 3. Then we get negative 2, negative. What happened here? Alright. And then we get negative. So that doesn't make sense. Oh yeah, negative 1. And then we get negative 2 again, and then negative 3. And then we put this on the graph, which I will draw again. Okay. That's okay-ish, I guess. So 1, 2, 3, 4. And then you get negative pi over here, right? Or 12, pi over 12. I gotta quickly write these in. Pi over 4. 5 pi over 12. And then 7 pi over 12. Now we're gonna graph them, right? Make sure to put in the asymptotes. So we have zeros over here. 2, 3, 4. Okay, hold on. Okay, and then we put 1 over here. Okay, and then there's also another one. Another. Okay, over here. Over here. Okay. And so then we graph the points. mind you, this is the main one that we'll be focusing on. Okay. So then we take these two. So you see that. Oh my gosh. Okay. I should have labeled this better. So we're gonna take. Okay. Wait, can you pause it? So, I just finished grabbing this, and so basically we take this one, right? This is the imaginary one. So this is the first one, and then we go through this one because it's negative, and then we go like this, right? And you see the point starts. Right, this one does too, and yeah, that's basically how you solve it. You make sure to have these ones going down as well. It's right here, right? So you have -3 right here, and then you go down. The same on the side with right here, and that's how you solve problem 9.
I love math. You don't love math? What's wrong with you?